It is go time. It's also ninja time. Okay? All right? So, before we take one step forward, I would like to take 18 steps backwards. So we're going to back that truck up just a little bit. Okay? So let's talk a little mathematical logic. Okay? By mathematical logic, I mean 6 plus something equals 6. What is that something? It's 0. Okay? So 0 is what is called the additive identity. Okay? I can add 0 to anything and nothing happens. Okay? That's what 0 does for me in addition. In multiplication, 9 times something equals 9. What's that something? 1. So 1 is the greatest math word ever, multiplicative. Just say that once. Multiplicative. Doesn't that just roll off the tongue? That just makes you want to do more math. Yeah! Okay? So 1 is the multiplicative identity. Okay? You probably have known this for years. Okay? You just probably never heard it referred to as the greatest math term on earth, identity. Okay? All right? Okay? So let's take those two concepts. Now let's go one step forward from where we were at the start. Okay? So if I've got a 2 by 2 matrix, -2, 3, -3, 4, and I want to add a matrix to that, but I don't want anything to change, okay? What's that 2 by 2 matrix going to be? Because it's got to be the same size. It's going to be what? First row is going to be 0 and 0. Second row is going to be 0 and 0. Yep. Okay. So it's going to be the matrix 0, 0, 0, 0. Right? Okay. So this is the 2 by 2 identity missed the T. What about the identity that one was for addition? What about the identity for multiplication? Some people might call it the multiplicative identity. Okay. This one gets a little more complicated, okay? Because now we're multiplying. And so to make the multiplicative identities, what you do is you put ones, you put ones on what's called the main diagonal. So you start in the upper left-hand corner with a 1, and then the diagonal running down and to the right all gets 1s. Okay? Everywhere else gets 0s. Okay? So we're going to fast forward one slide, and then we're going to come back and we're going to actually try that. Okay? All right? So that's the 2 by 2 multiplicative identity. What would the 3 by 3 look like? Left to right, top to bottom. It would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Yep, so it would look like that, right there. Okay? So that's the identity matrix for a 3 by 3. A 4 by 4 would be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. All right? 1's down the main diagonal, 0's everywhere else. Okay? So, now, let's go back and let's try this because we're going to actually use this. Okay? We're going to use this identity concept here today. Okay? So let's do that matrix multiplication. So, I'm going to take the first row times the first column. Negative 2 times 1 is negative 2. 3 times 0 is 0. Negative 2 plus 0 is negative 2. So far, I'm good. Okay? Then, I'm going to take the first row times the second column. Negative 2 times 0 is 0. 3 times 1 is 3. 0 plus 3 is 3. Golden on 2 occasions. Then, I'm going to take the second row times the first column. Negative 3 times 1 is negative 3. 4 times 0 is 0. Negative 3 plus 0 is negative 3. 3 for 3. Then, I'm going to take the second row times the second column. Negative 3 times 0 is 0. 4 times 1 is 4. 0 plus 4 is 4. And these ended up being exactly the same. So it works out. Double tap. Okay? Now, let's back the truck up again. Beep, beep, beep. Okay? Okay? I don't have the slide ready to go. Okay? So, inverses now. Okay? The additive inverse is what you add to a number to get the additive identity. So 6 plus what gets me 0? Negative 6. Okay? So that means that negative 6 is the additive inverse. Okay? Multiplicative. The multiplicative inverse is what you multiply to get the multiplicative identity. So 9 times what gets me 1? 1/9. Okay? So 1/9 is the multiplicative inverse. Now, we've got other names for those. What do we call negative 6 when we're comparing it to positive 6? Old word. Opposite. Okay? What do we call 1/9 when we're comparing it to 9? Reciprocal. Okay? Right? So we have other words for them that we also use. Okay? But today we're going to focus on identity and inverse. And really, addition, whatever. Okay? What we really want is we want that multiplicative because it's the greatest math term ever. Okay? Right? So, we need to figure out how to find inverses of matrices. Okay? Now, We are not going to ask you to by hand find an inverse bigger than a 2 by 2 because the math just gets complicated. It can be done, but it ain't fun. Okay? All right? So, to find the inverse of a 2 by 2 matrix, okay, we could follow all of this stuff. So, what we're going to do is we're going to start with matrix A. Matrix A is a 2 by 2 matrix, and right now we're just going to call it ABCD. Okay? First row is AB, second row is CD. Okay? So, the very first thing that you should do is you should find the determinant. Remember, the determinant is A times D minus B times C. Okay? The reason that you find the determinant is because the reciprocal of the determinant is a scalar. It's going to be scalar multiplied by our inverse. So 1 over the value of the determinant goes in front of my inverse. Okay? So that could be a fraction. And honestly, I would leave that fraction out in front all the time. Unless it's a nice one like 1 or negative 1. Okay? Then you could multiply it in if you need to. Okay? But otherwise, just leave it out in front, and you'll see why in a minute.
Is that the 1 over absolute value of A? Is that what that is?
Well, that's absolute value of A is determinant of A in matrices.
So that's the same thing as you just wrote down?
Yes.
Okay.
Yep. Yep. So far what we've found is this part right here. Yep. Okay. Now, what happens in the actual matrix is it's a twofold concept. Okay? So first, you are going to switch the two numbers, or the two elements, if you will, on the main diagonal. Okay? So these two numbers right here switch spots. Those two elements. D goes where A goes where D was. At the same time, you are going to negate the other two. So it becomes negative B and negative C. Okay? Now, that's it. You just found the inverse. Okay? So, let's put that all together one more time for old time's sake. Or first time's sake, whichever one you prefer. Okay? So, my matrix is A, B, C, D. The inverse of that matrix is going to be, first I'm going to find the value of the determinant, right? So that's going to be 1 over AD minus BC. And then inside my matrix, I switch A and D. And I negate the other two. Okay? Soak that in. let's find the inverse of an actual 2 by 2 matrix. Okay? So my matrix is 3, 8, 2, 5. So the first thing that I need to do is I need to find the value of my determinant. Correct? Okay. So that is going to be what? 3 times 5 minus 2 times 8. Yes'm? Okay. So that is 15 minus 16, which is negative 1. Correct? Correct. So the value that goes outside my determinant is 1 over negative 1. Okay? Now, inside, left to right, what is my matrix? 5, negative 8, negative 2, 3. Fantastic. I would accept that as an answer for the inverse. But the outside fraction is really equal to negative 1, so we could really distribute that negative 1 in there to be negative 5, positive 8, positive 2, negative 3. Those two are equivalent. Okay? Not every time is the value of your determinant going to be nice and easy like that, where it's 1 or negative 1. Okay? Just so happened on this one that it was. Okay? I got an answer. 92. Probably should let her ask the question first.
For the absolute value, don't you have to change the negative 1 to a 1? Or no?
It's not absolute value. It's determinant.
Why are there absolute values?
Because that's the symbol for determinant. This right here in this purple circle, yes, it looks like absolute value, but because we're dealing with matrices, it's determinant. Okay? As my phone is blowing up over here. Who be calling me? No idea. Okay? With me? So it's not automatically switching to positive. Okay? Let's go with number 1. Find the value of that determinant. Or I should say, find the inverse of number 1. So, the value of the determinant here in number 1 is 22. Do we agree with 22? Because it's 6 times 4 minus 2 times 1. So that's going to be 22. So my inverse is going to be 1 over 22. Okay? Then my matrix is 4, negative 1, negative 2, and 6. Yes? Okay? Now, you can leave it like that. You don't have to distribute that 1/22 into it. If you want to, more power to you. Okay? But you don't have to. Okay? On a calculator, which you'll learn tomorrow and Friday, I want to say, the calculator does it for you. It will distribute it in for you. Okay? But actually finding the inverse of a 2 by 2 is faster by hand than it is on the calculator. Okay? Just so you know. Okay? Very quickly doing this one over here. Negative 8 minus negative 20 is going to be 1 over positive 12, and then it's going to be 8, negative 5, positive 4, negative 1. With me? Okay, fantastic. Now, we're going to be talking today about inverse operations. You do inverse operations all the time. Okay? When you're solving equations and you add something to both sides to move stuff around, that's an inverse operation. When you're multiplying and dividing, those are inverse operations. Squaring and square rooting, inverse operations. Later on, we're going to get into some trig where you're going to take the sine and the inverse sine. And those are inverse operations. Okay? Today, we're going to do some matrix inverse operations. Okay? So we're going to have a matrix equation set up like this. Okay? Where we're going to have a matrix A times a matrix X, and that's going to equal a matrix B. And in order to solve that, we are going to multiply by the inverse. So what happens when you multiply by an inverse? 9 times 1/9 becomes 1, and then it's the do nothing part, right? So this part goes away with matrix. But now, as some people were learning from the video last week for Friday, and from doing their Q5 homework, order matters when you're doing multiplication of matrices. So, because we multiplied on the left side here of that one, I'm going to have to multiply on the left side over here. Because I multiplied on the left side of the equation, I've got to multiply on the left side of the right side of the equation. Order matters when you're multiplying by matrices. Okay? Otherwise, it doesn't work out. The dimensions don't work out. Okay? So that's going to be crucial. So, let's jump right in to solving by matrices. Okay? Now that I've got you confused, let's clear it up. So, here is a system of equations. Okay? Negative 2x plus 3y equals negative 11. 5x plus y equals 19. That's my system of equations. If I want to set that up into a matrix equation, the first equation that I'm going to do is going to be the coefficients of my variables. In order, left to right, top to bottom. My second matrix is going to be the variable matrix. My third matrix is going to be the constant matrix. Now, if I were to do this math, row times column, negative 2 times x is negative 2x, 3 times y is 3y, I get negative 2x plus 3y. I get the left side of my system. 5x plus y, left side of my second system. Okay? So it all works out in there. Now, in the abstract, what's going to happen here is I am going to take the inverse, oops, that's a bad writing. I'm going to take the inverse of my coefficients matrix, and I'm going to multiply that by my coefficient matrix times my variable matrix, and that's going to equal, because I added this orange matrix, this inverse matrix on the left side, I've got to add it to the right side, or the left side, over on this side. Now, here's the nice thing. Let's go with Oklahoma. This side cancels out. So all that's left over here is the variable matrix. Okay? So let's find the inverse matrix of my red one. What is the value of the determinant of that red one? Negative 2 times 1 minus 5 times 3 is negative 17, right? So that's going to be 1 over negative 17 times 1, negative 3, negative 5, negative 2. Agree with me on that? That's going to be multiplied by negative 11, 19. Okay? So let's do that. I'm going to drag along this 1 over negative 17 and keep it until the end. Okay? So this becomes 1 times negative 11 plus negative 3 times 19 and negative 5 times negative 11 plus negative 2 times 19. So that is negative 11 minus, what is that, 57? Yeah? Negative 11 minus 57 is negative 68. Positive 55 minus 38. 17. Okay. Now I'm going to distribute that in, because that's going to give me my answer. So x is 4, y is negative 1. And I can write it like that, or I could write it in point form, or I could write it like that. Okay? Let's set one up now. This is Q7, yes. Okay. So, my matrix equation is going to be what? What is the matrix equation here? 4, 7, and 2, 3. Next one is xy, negative 16 and negative 4. Okay? So I'm going to take the inverse of my coefficient matrix, multiply it on the left side, on both sides of my equation. So that's going to give me xy here is equal to, all right, so the inverse of that matrix is 1 over what? Negative 2 times 3, negative 7, negative 2, 4 times negative 16, negative 4. Right? Okay. So that's 3 times negative 16 plus negative 7 times negative 4, negative 2 times negative 16 plus 4 times negative 4. So that is 1 over negative 2 times negative 48 plus 28 is negative 20. 32 plus negative 16 is 16. So that gives me x and y here as positive 10 and negative 8. Yeah? And that checks out, because if I put 10, 40 minus 56 is negative 16. 20 plus negative 24 is negative 4. Checks out. Okay? Very quickly setting this one up. I'll just set it up quickly for you. 1, negative 1, 9, negative 10, x and y, 4 and 45. So then x and y here, bless you, is going to be, that's negative 10, so that's 1 over negative 1 times negative 10, positive 1, negative 9, positive 1 times 4 over 45. So that's going to be negative 1 times negative 40 plus 45 is 5. Negative 36 plus 45 is 9. Right? Negative 40, positive 45 is 5. Negative 36, 45 is 9. So that gives me x and y here as negative 5 and negative 9. Quick check. Negative 5 plus 9 is 4. Negative 45 plus 90 is positive 45. Yep. Okay. Have yourselves a great, grand, and wonderful day.